the equation of a line is true for all points on that line. We can use this. If we have the equation of a line, we can figure out whether a point lies on the line without even drawing the line. We don't have to look at the line. We don't have to see it. We don't have to make a table of values and plot the line and Cartesian plane and blah, 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 blah. We can tell if a point is on the line just through algebra. Let's see how it works. To see if this point lies on the line, notice in this point that x is 2, okay? There's the x and there's the y. So let's imagine a world where x is 2. Let's pretend that x is 2 and see what happens. If x is 2 then, well, we can write the equation of the line, y is 5x plus 2. We can substitute x with 2. We can replace x with 2. And we can see what happens. We can see what y would be. Well, this right-hand side, I'll replace x with 2. 5x means 5 times x. So this is 5 times 2. And I'll copy down the plus 2 without changing it. Now I can figure out this 5 times 2. I know that that is 10. And add 2 to get 12. So if x was 2, then y would be 12. Is y 12 on this point? No! 12 is not equal to 3. Do you notice this symbol here? It's an equal sign with an angry line through it, saying 12 is not equal to negative 3, I should say. So it is not on the line. We just proved if x was 2, y should be 12. It is not 12. Therefore, it is not on the line. This point does not make that equation true. Let's try another one. Does 3, 17 lie on the line? Well, let's imagine a world where x is 3. If x is 3, then y would be 5x plus 2. Write down the equation. And the equation, just copy it from the question. Equals 5x means 5 times x, and x is 3. So I will replace x with 3 and put that invisible times sign back in. I copy down the add 2. And then, okay, so now I've got 5 times 3. I can replace this. 5 times 3 is 15, and 15 plus 2 is 17. So if x is 3, then y would be 17. That matches this point. So it is on the line. This point makes that equation true. Therefore, this point would be on that line if we graphed that line. We can also use a similar algebra to figure out what one coordinate should be, like what y should be, if we know what x is. Imagine you've got a formula for the dosage of a drug based on your weight. Well, if you know your weight, you can figure out how much the drug dosage should be if you're a pharmacist or a doctor, for example. So we've got a point lying on the line. We're told that it lies on the line, so we know that it makes this equation true. And we're told that its x-coordinate is 4. So we're going to imagine a world where the x-coordinate is 4. And we know that this equation will be true, so y equals 5x plus 2. We're going to write this again, but we're going to replace x with 4. We're going to substitute x being 4. So y equals 5 times x plus 2. Do you notice that I copy everything from the line above? I've just replaced x with 4, but everything else I copy down. That is important. Now I can do the same again. So therefore, y equals 5 times 4 is 20. 20 plus 2 is 22. So if x is 4, then y is 22. We can go backwards as well. Here, we're told what the point's y-coordinate is, rather than its x-coordinate. We can do the same sort of thing. Let's imagine a world where y is 4. Well, if y is 4, I can write down this equation, which we know will be true because the point lies on the line. And now I'm going to substitute y with 4. What will this equation look like after I've replaced y with 4? Y gets replaced with 4. Everything else gets copied down. Important that you do that. Everything else gets copied down. Now I can figure out what x is. There are a few ways of doing this. One way is to note that I have one term on this side and two terms on the other side. This term is positive 2, and I can move the term to the other side where it becomes the opposite. It was positive 2. When I move it to the other side, that term will become negative 2. 4 minus 2, negative 2. The 5x is still on the right-hand side. 5x is still a term by itself on the right-hand side. And now I've got these two terms on the left-hand side. The reason that I did that is so that the constants, the numbers, are together on the same side. Because now I can replace 4 take 2. I know what that is. I can put that in a calculator or do it in my head. 4 take 2 is 2. So we'll write this equation again, but we're going to replace that with 2. Notice that everything else I copy down. The equals gets copied down. The 5x gets copied down. I put a therefore sign in front of it, the 3 dots. So therefore 2 equals 5x. There are a few ways to solve this. One way to solve it is to recognize that this means 5 times x. 5 times x, put a little invisible times there. So x has been multiplied by 5. We can move that multiply by 5 to the other side. It will become the opposite. The opposite of multiplying by 5 is dividing by 5. So x is 2 divided by 5. If you're not confident with this stuff here, then I have other videos on solving linear equations. You want to get better at solving linear equations if this is a bit unclear. If I remember, I'll leave a link in the description to solving linear equations. And I hope this has been helpful. So many things you can do with points and lines without even needing to draw the graph. Brilliant. All right, I'll see you in the next video. Bye, everyone.